Okay, so who had a question about one of them? Yes, 7. Okay, let's take a look at 7. See what's happening there. Okay, this is another one of those kind of factor label things where we got to change. Let's see, what are we changing from? We are going 72 revolutions per minute. So we're going to start with 72 revolutions per minute. And eventually, what do I want to end up with? Miles per hour. So we just have to get from this to that. Well, the minute hours thing is the easy part, right? So we can take care of that right away. So we'll say, okay, there are 60 minutes in 1 hour. That's done. Now, we somehow have to get from revolutions to miles. So let's look at this wheel again. We have the tire has a radius of 1 foot. Remember, there's a key piece to this now. We talked about it yesterday, I think. What's the key piece? Circumference. 1 revolution is a circumference, right? So we know that this wheel is going to travel how many or how far in 1 revolution? What's its circumference? 2 pi r, which for us would be 2 pi feet. So we know that 2 pi feet is 1 revolution. Would everybody agree with that?
Yeah.
Now, you've got feet, you need miles.
5,000 something feet.
1 mile is 5,280 feet. Now, what unit is left? Everything crossed out except hours on the bottom and miles on top, which is what we wanted, right? Isn't that what we wanted? Got it? Okay, anybody else? I heard some talk about number 6 before the bell rang. Do we remember? What's kind of the key formula for number 6? Arc length equals radius times radius. Arc equals radius times radians. So when I look at problem A, it says, okay, I got the circle here, the radius is 8, and the central angle is 40 degrees. What's the matter?
One's at 40 degrees.
If I'm going to use this formula, my angle has to be in radians, so that's good practice for us. We need to be able to convert back and forth. How do we change degrees into radians?
Proportion of
Pi is to 180 as something is to 40. That's right, these two equal. Pi radians are 180 degrees, so we want to know how many radians are 40 degrees. So that's 40 pi over 180, which reduces to something. 2 pi over 9? So now it's a super simple problem. We want to know what the arc length is. It's simply going to be 8 times 2 pi over 9. So the answer is 16 pi over 9. Is there a unit? No. If this had been 8 feet, then this would be 16 pi over 9 feet. Vaguely familiar now? All right, anything else on that before I start talking about part 1? Anything else on that sheet? Maggie?
I was just a first, so if we go over the secant 2 pi,
Find the secant of 2 pi. How many degrees are we talking about here? We're going to find the secant of 360 degrees. Where's 360 degrees? It's right here, isn't it? All the way around back to our starting spot. We call that a quadrantal angle, remember? And what do? Pick a radius, and we usually use 1. And if we pick a radius of 1, that is the point 1, comma 0. There's no triangle. Don't make a triangle. I know we like to make triangles, but we can't if the angle's quadrantal. So this says that x is 1, y is 0, because I picked a radius of 1. What's secant by definition? Reciprocal of cosine. Okay, so what's cosine? X over r. So we need r over x. So r over x would be 1 over 1. So the answer is 1. Okay? All right, well, let's look at part 1 now. No calculator for the ones with the stars. So let's do those first. Then we'll get our calculators out and do the other ones. We are solving trigonometric equations now, kids. This is kind of an important skill. We've talked about this a little bit, but really not very much. Please note the directions. We are going to answer the questions in radians because the directions tell us we're going to look for numbers between 0 and 2 pi. If we had these directions, then we would be answering in degrees. So how you answer, you're looking for angles. The answer to this question is going to be angles. The unit you use to answer will be in the directions. If it says 0 to 2 pi, that's radians. 0 to 360 would be degrees. Strategically, we're going to do the same thing no matter what. It's just whether we're going to say 60 degrees as our answer or pi over 3 as our answer. Okay, deep breath, here we go. Where would I look in my circle? Where would I look to find a cosine that is a negative number? Quadrant where?
What about quadrant 4?
What'd you say? Why 2 and 3? Because it's negative. Cosine is negative, and which letter is cosine associated with, x or y?
X.
X. Where is x negative, groupies?
2 and 3.
2 and 3. Very good. So there I am. My answer is either going to be a quadrant 2 angle or a quadrant 3 angle. Actually, both. I'm going to write down both answers. Okay? Now, let's look at just one triangle at a time. These are congruent triangles, so you don't need to worry about it. They're going to be exactly the same. I'm going to look at this one. If the cosine is negative 1/2, I should be able to label part of this triangle. Where should I put the 1 and where should I put the 2 if that's the cosine? The 1 is going to go here, right? And the 2 is going to go here. How do I know that? We just talked about it. Cosine is x over r, or adjacent over hypotenuse. Now, by the Pythagorean Theorem, what's this side going to be? Now, if I'm expecting you to do this without a calculator, that kind of thing has to happen. What do you know about that triangle right there? It's a 30, 60, 90 triangle, right? If you're doing it without a calculator, it has to be something special. It can't be a 17-degree angle. If it's no calculator, you better get something that looks like that. Okay, so this angle's how big? What?
60.
That's 60, yeah, remember, across from the root 3. Across from the root 3. Now, here's where you have to pay attention. Okay, this triangle and this triangle are congruent, so this is also 60. But 60 is not an answer to the question. The reference angle is 60. But remember, when you answer, you must answer in standard position. So what is the answer? Not 60, but 120. The red one is 120. And then what about the other angle, which would be the purple one? How big would he be? 240. Now, for those of you that aren't keeping up, remember, a semicircle is 180. So if you're going the red angle, you're going 60 less than that, so you're going 120. If you're going the purple angle, you're going 60 more than that, so you're going 240. So your answers are 120 and 240. Except what? We have to change it to radians, right? Now you have a choice here. It's whichever you're more comfortable with. You can go ahead and change both of these into radians. And we'll do that the same way we did a minute ago. For example, for the 120, I would say pi is to 180 as something is to 120. So I have 120 pi over 180, which reduces to 2 pi over 3. So this one's 2 pi over 3. This one's just double that, so it would be 4 pi over 3. Now that will always be an option. If you prefer, back in the beginning when I was still doing the problem, instead of calling that 60, I could have changed that into radians right there. So 60 is a third of 180, so this would be pi over 3. Now, for some of you, that's going to be a little bit confusing, but I think some of you can do it. A half a revolution, a semicircle, is pi, right? A whole pi. So with this much as pi over 3, the red angle would be pi minus pi over 3. So 1 minus a third would give you the 2/3. And then 1 plus a third would give you the 4/3. Somehow, you got to come up with these two answers. But how you do that's up to you. Okay, Harry, you excited by that?
I'm super
I
excited.
can tell that, okay. Let's look at the next, no calculator one. Let's look at D. Then we'll get our calculators out and do the other ones. So the cosecant is 2. I don't work very well in cosecants. So would it be okay with you if we rewrote the problem as sine equals 1/2? Are those the same thing? Did he say the same thing? Yeah. I feel better about sines. May not be an issue for you, that's okay. I need it, this makes me happier. All right, so I'm gonna draw a picture of this. Where will I draw my triangles this time? 1 and 2. And I know I'm going to draw my triangles in 1 and 2 because why, Delaney?
It's y.
It's y. And y is positive. And where is y positive? Up here. Exactly. Sine is y over r. Now let's see. Sine is y over r. I have the same kind of triangle, don't I? Only this time, be careful, the reference angle is across from the 1. So this is not a 60. This is a 30. I'm going to change that to radian. 30 is what fraction of 180? Pi over 6. If that bothers you, do it in terms of degrees. Do 30. This time, is 30 or pi over 6 an answer? Mm-hmm. That's one of your answers right there. So one of our answers is pi over 6 or 30 degrees right there. What's the other one gonna be? This little red one gonna be? 150 in terms of degrees, so you can go ahead and change that into radians. Or, remember, all the way to here would be a whole pi, right? If we don't go 1/6, how much have we gone? 5/6? Which is 150. So if you did it in terms of degrees, you're going to get 5 pi over 6 when you change it. Everybody okay with that? All right, let's look at the ones that use a calculator. First thing you're going to want to do is put that calculator in radian mode. We haven't talked about that yet since we've been back, but it is a big deal what mode you're in. So make sure that if you're doing a problem in radians, that your calculator is set in radians. All right, here we go. Now, even though we are using a calculator, there's still part of this problem you have got to do by yourself. And that is, you've got to figure out where your answers are going to be. Your calculator is going to give you the angle that you need, but you've got to figure out where that angle is, okay? So once again, we have a positive sign. Where is the sign positive? 1 and 2. So there are going to be 2 answers to this problem. Your calculator is going to help you find them, but you still have to do this work on your own. All right, so I'm set in radian mode. Anybody remember how we find angles on our calculator? I need this angle. I got to find this angle right here.
Second cosine.
Second, not second cosine, not
Second
this
sine.
problem. Second sine. I want to find the angle whose sine is 1/3. So I type second sine 1 divided by 3, and it says about 0.34. I'm going to go ahead and round it off. Would you agree with me, 0.34? Remember, this is a radian measure, so we expect a decimal. Okay? So what are the answers to the question? Is one of them 0.34? What's the other one? How are you going to find the other one? What are you going to have to do? What?
Pi minus.
You are on fire today. You are good first period. Good. She says, all the way to here is pi. I only want to go this far, so I'm going to take pi minus 0.34. And she is exactly right. So the other answer is 2.80. If we were doing this in degrees, and I knew, I'm going to make a change here for a minute. If we were doing this in degrees and I knew that was 70 degrees, then wouldn't I do 180 minus 70? So that's exactly what we're doing right now. Only we're saying pi minus instead of 180 minus. Easy. All right, let's try this one. Where is the tangent positive? 1 and 3. Very good. And how do I know, Maggie, that the tangent is positive in 1 and 3? Everything's positive in quadrant 1. But in quadrant 3, what happens to x and y?
They're both negative.
They're both negative. So when you build the fraction, y over x, they become positive. All right, what buttons do I press on my calculator?
The
Second tangent, 4/5,
Right.
and I get 0.67. So both of these little reference angles are 0.67. So what is this answer? People, what's that one? 0.67. Yeah, first quadrant, that's it. How are you going to find this one now? What are you going to do to get that answer? Pi plus 0.67. Exactly. You're going to go 180 plus this angle. Pi plus that angle. So plus pi 3.82. Everybody okay with that? All right, let's look in our book and look at a little more challenging problem. Would you look on page, section 4.5. Okay, so it's page 402. And let's take a look at number 37. Now, you guys, you got to pay really close attention to the directions on these problems. We're on page 402. We're looking at problem number 37. These directions, I'm not sure why this guy did this, but he made the directions kind of crazy. You really have to pay attention to them. Can anybody tell me what this means? It's in quadrant. The bottom right one stripe. What number would that be? No, that's not 3. Oh my goodness gracious. There. Yes, you're right. It's in the bottom right one. It's in quadrant 4. So this says this time there's only going to be one answer. They're telling you that any answer you put down has got to be in this boundary, which is quadrant 4. Now, in case you're confused about how he knew that was the bottom right quadrant, remember 0, 90, 180, 270, 360, right? In radians, that's 0, half pi, whole pi, 1.5 pies, and 2 pies. So if we're saying 1.5 to 2, that's right here. Now, what about that? How about that? Well, first of all, that's not even a fraction. And I need it to be a fraction.
Put it in tangent.
So, well, yeah. And then it's a cotangent, and I need a tangent. So let me rewrite this first. What would this be in terms of a fraction? I could do 6 over 10, but I could also do 3 over 5. You need a fraction, gang, because you're going to label the sides, right? Okay, and then I don't do cotangent, so that means the tangent is what? If the cotangent is negative 3/5, the tangent is negative 5/3. So let's look at this. Negative 5/3, that's a tangent. So where am I going to put the 5 and the 3? 3 is the x, so that's negative 5. Oh. Okay, I'm in trouble. Is that one of my special triangles? Is that, I can find this,
No.
but is this going to be one of the special ones?
No.
No, your job is to find this angle right here, so you're going to need to use a calculator. You're going to have to use a calculator. So what will that be? Second tangent 5/3. I'm just gonna give you a little Lisa Fordism. I never put the negatives in. I've taken care of the negative by drawing the picture here. With the cosine function, with tangent, you're gonna be okay, but with cosine, when you put the negative in, it's gonna mess things up. So try, just bag the negative, just type second tangent 5/3. As long as you have your picture drawn in the right quadrant, the negative doesn't matter anyway. So just leave the negative out. This turns out to be 1.03. If you put 1.03 down as the answer, you'll be wrong, because 1.03 is this angle right here. The answer to the question is this angle. How will we find that angle?
2 pi.
2 pi minus, very good. So we'll take 2 pi minus that answer. So the answer to the question is 5.25. Does everybody understand why we did this time 2 pi minus? Yep, Maria just went like this. She's exactly right. We went all the way around, except that little bit right there. Okay? All right, hang on to your hats, because now we're going big time.
We're not allowed to wear hats.
I'm going to give you something else to Twitter rage about. How about it?
I like that. I have like a 5 minutes.
And just for
We
kids,
would not
All school ran.
let's do this one in terms of degrees.
be attacked.
All right? So here we go. We're going to do this one in terms of degrees. You're looking at this thinking, oh my gosh, it's got a squared in it. Yes, it does. But we can do it. Zach Bat? An idea on how to start?
Go back.
Think of a regular equation. Forget the fact it's a cosine. What would you do if this were just a plain x here? What would you do? You can't do that yet, sweetie. Zach, back. Look, you're walking down the hall and you find this equation. What do you do?
Come find you.
Add 1 and divide by
4.
4. So if we do that, if we add 1 and divide by 4, now we have this. Just regular arithmetic. What's your thought now? Square root both sides. So cosine will equal plus or minus. Remember, when you take the square root, you got to do plus or minus. What's the square root of 1/4? 1/2. So now you got an equation that looks sort of like the ones we were doing. Where does the cosine equal plus or minus 1/2? All right, so what quadrants would we be looking at, kids, if the cosine is going to be plus or minus? What'd you say?
Everyone.
Every one of them. Every one of them. Cosine is positive or negative everywhere. So you're going to have 4 answers this time. All of these triangles are congruent, so you only really need to work in one of them. So if I work right here in the first quadrant, I need to know what that angle is. Well, the cosine is 1/2. Can I label this triangle if I know the cosine is 1/2?
Yeah.
This would be 1 and this would be 2, correct?
Yeah. Another 1 square root.
The other one's a square root of 3. No calculator necessary. Because what do I know about this angle right here?
60.
60. And I'm doing degrees this time, so I'm just going to leave it 60. That means all of these are 60s.
Same with that.
They're all 60s. So we want a first quadrant 60, a second quadrant 60, a third quadrant 60, and a fourth quadrant 60. So anybody have any ideas what our answers will be? First quadrant 60, very good. How about the second quadrant? 120. How about the third quadrant?
180.
No, 180. Which I can't do in my head, but that's the answer.
Oh, right.
240. And what's the fourth quadrant? 300. Very, very good. Now, I want everybody to make sure you understand where all four of those angles came from. 60 is in quadrant 1, it's that special right triangle. In quadrant 2, it's 180 minus 60. In quadrant 3, it's 180 plus 60. And in quadrant 4, it's 360 minus 60. Got it? Okay. Here's the deal. Tonight you are going to do 4 equations on your own. You have 4 minutes. You can start the first one right now and probably get it done. So your first problem is 29. Your second one is 31. Same page, 402. So you're doing 29, 31, 35, and 39. Please follow the directions. That's all of your homework.
Are you sure it's 402?
Yes. If you still are unsure about some of that review stuff, spend some more time on that too. Would you turn the video off? What did you say?
Bad.